In the 17th century, the philosopher Mulla Sadra established a metaphysical doctrine known as the primacy of existence, or asalat al-wujud. The core axiom of this framework is strict. Existence alone possesses objective reality. Everything else, what we categorize as essences or forms, are merely conceptual abstractions produced by the intellect. But modern scientific frameworks like systems theory and the Brain Kinematics Model rely heavily on the concept of a continuum to explain how complex reality actually operates. If we define the continuum as a separate, independently existing entity, or a new type of physical substance, we break Sadra's metaphysics. Introducing a parallel reality directly contradicts the rule that existence alone is real. Adding a third ontological category alongside existence and essence would compromise the internal logic of the entire philosophical system. Without a resolution to this tension, we have to choose between maintaining a coherent metaphysical baseline and utilizing the functional models that accurately map physical reality. The continuity theory resolves this tension by proposing that the continuum is neither an additional substance nor a rival category. Rather, it is the intrinsic mode of organization through which existence continuously preserves and transforms itself. Think of mass and space-time in modern physics. Mass is not a separate universe competing with space-time. Mass exists within it. Similarly, the continuum is not a separate object. It is the organizational structure unfolding through existence. By defining the continuum as a mode of existence, the primacy of existence remains fully intact. We maintain the strict metaphysical baseline while gaining a mechanical explanation for how systems organize and change. Classical philosophy traditionally draws a strict boundary between static structure and dynamic motion, treating them as distinct phenomena where change acts upon a fixed form. The continuity theory removes this boundary by analyzing systems at infinitesimal organizational intervals, defined mathematically as epsilon space and epsilon time. When we observe organization at these elementary scales, the distinction between a static form and its active change dissolves completely. A physical structure cannot exist independently of ongoing transformation, and motion cannot occur without an organized structure capable of changing. At the smallest meaningful interval, structure and motion become a single, inseparable unity. This establishes a reciprocal rule. Structure is organized motion, and motion is continuously transforming structure. We define this absolute unification of state and change at the epsilon interval as an elementary continuum. The foundation of the physical world is not constructed from rigid objects pushing against one another. It is built from continuous, interdependent, self-organizing transformations. These elementary continua are not trapped in microscopic local neighborhoods. They scale upward and project outward. As an organizational wave moves through a dense medium, the local matter in its path rapidly changes position and state, yet the overarching shape and regulatory relationships within the wave itself remain perfectly intact. This propagation mechanic appears throughout physics, driving everything from mechanical and electromagnetic waves to fluctuating quantum fields. We see the exact same process operating in complex biology. Embryonic development and macroecological networks maintain continuous organizational coherence, even as their individual cells and organisms constantly die and are replaced. A system's persistence is determined by the continuity of its organization, not the permanence of its material constituents. True identity belongs to organizational continuity. A physical entity remains itself because its structural relationships are preserved, even while undergoing substantial physical turnover. We can test this principle using the Brain Kinematics Model to examine human cognition. If we look exclusively at static neural pathways and synaptic maps, we find structural potential, but no active thought. Conversely, if we isolate only the transient neural strain waves traveling through those pathways, we find random energy transfer, but no coherent cognition. Cognition requires a continuous feedback loop. An organized neural structure constrains the propagation of a strain wave, and that propagating wave simultaneously reorganizes the neural structure. When millions of these interdependent loops interact, they synchronize into massive higher-order phase waves across the brain. Memory, emotion, and perception are not stored as physical objects in isolated regions of tissue. They emerge as these specific, higher-order organizational continua. The brain does not function as a rigid hard drive storing static data points. Consciousness emerges as a highly evolved regulatory continuum formed by the constant, inseparable interaction of organized structure and continuous motion. A recurring error in analyzing these systems is conflating the mathematical concept of continuity with the actual ontological reality of a continuum. These handwritten differential equations demonstrate how we use dense formal languages to map universal behaviors and track complex systems. Mathematical continuity describes how organizational continua behave, but the equations themselves are not identical to the physical reality they represent. Maxwell's equations accurately describe the mechanics of electromagnetic fields, but the equations do not generate the fields. Similarly, Schrödinger's equation describes the evolution of a quantum system over time, without being the physical quantum state itself. Over centuries, mathematics has evolved progressively richer descriptive tools, moving from basic algebra into advanced topology, through continuum mechanics and dynamical systems, to better track continuous organization. Mathematics serves a specific vital role. It is the formal language we use to measure, analyze, and predict the behavior of continuous systems. If we fail to separate the map from the territory, mistaking the mathematical language for the underlying physical ontology, we fall into reductionism and obscure the actual mechanics of existence. The continuity theory provides a framework to extend classical ontology into the mechanics of modern science. Reality is a three-tiered structure: existence, organizational continua, and mathematics. Each tier answers a question. Existence asks, what is real? The continuum asks, how does existence organize and transform? Mathematics asks, how do we formally describe and predict those transformations? Mulla Sadra's primacy of existence and the physical mechanics of continuous systems are not in conflict. They are complementary layers of a unified worldview, providing a logic that connects the fundamental nature of being directly to human consciousness.